Let's learn about line graphs. A line graph has a y-axis and an x-axis. These are almost always interval ratio data, and they have an obvious sequence. So let me show you an example of one of my favorite line graphs that I use in my remote sensing class. So down here on the bottom, let's have months. So this is January, February, March, April, May, June, July, August, September, October, November, and December, okay? Okay, so we have an entire year here. We could have done days, right? This would be day 0, and this would be day 365. 175, 170 is in here somewhere, right? We could have the days spaced out across the bottom. Here along the y-axis, we're going to have a vegetation index. So this is, we're not going to go into that, but this is an estimate of how much photosynthesis is happening at a satellite image. And it's going to range from there is 0 photosynthesis happening here to, sorry, that's not actually a percent. I'm getting in the habit of writing percent signs. It ranges up to 1. So 1 would be the maximum amount of photosynthesis that could occur in a pixel. So here we would have 0.5, 0.75, and here 0.25, right? So our graph would look like this. In winter months, we would have very low vegetation. In fact, I'm going to make this line a little bit thicker. But we would have very low vegetation in the winter months. We might even have, some snowfall that completely covers whatever vegetation is there. By the time we get into spring, it starts to go up. In the summer months, we flatten off. And when we get down into the fall months again, well, that probably would have happened sooner, but the fall months, it drops back down to our base value there, okay? Yeah, that's not completely accurate. It probably would have, August, September, maybe it would hang on that long. Okay, but this is a line graph. We're showing a sequence, an idea that moves sequentially, or a piece of data that moves sequentially across some understandable order down on the bottom. Okay, so it's not just frequencies, but we're specifically moving in a sequence, and that's why we draw it as a line, right? As a line, we clearly see that this point, this point here gives way sequentially to this point, which gives way to this point sequentially, right? And since we're dealing with a sequence, we put in a line so that you can follow the entire trajectory of the phenomena, in this case across time. But it doesn't have to be across time. It can be across any logical gradient along the y-axis.